The twin paradox is a common problem discussed concerning relativity. It is also used by opponents of relativity as a reason for opposing it. However, it is actually easy to explain, and it can be done without invoking general relativity. It simply involves looking at the entire problem and not just one part of it. What is commonly ignored is the effect of length contraction. But when this is considered, the problem is solved and there is no paradox. The example we will use here is a trip to Gliese 393, a red dwarf star 23 light-years away. It has 41% of the Sun's mass and radius, but is only 2.35% as bright and cannot be seen without a telescope. This small star was chosen for this example because its distance was best for the illustration. We start with two twins on Earth at age 34. At this point, one of the twins heads off to Gliese 393 at 0.999 times the speed of light. This produces a gamma factor of 23. When the one going to Gliese 393 arrives, he's experienced only a year's travel time and is now 35. His twin back on Earth, however, has experienced 23 years and is now 57. After spending a year surveying the system, the twin that made the trip heads back to Earth and is now 36 years old, while the twin that stayed on Earth is 58. When the twin that made the trip to Gliese 393 arrives back at Earth, he has aged an additional year during the return trip and is now 37. However, his brother that stayed on Earth experienced another 23 years and is now 81 years old. The reason this looks like a paradox is that if the laws of physics are supposed to be the same for all observers, why does one age slower than the other, when they can each consider themselves to have been at rest? The problem with this reasoning is that length contraction is not taken into consideration, and once it is, the problem is solved. Now let's take a look at what the twin that stayed on Earth would see. The twin that stays on Earth says goodbye to his brother. They are both now 34. His brother then heads off to Gliese 393 at 0.999 times the speed of light, which has a gamma factor of 23. From the perspective of the twin staying on Earth, the ship is shortened to 1/23 its length. The twin that stays on Earth watches the ship go 23 light-years at nearly the speed of light, and when it arrives, 23 years have passed. He is now 57. After his brother has surveyed the system for a year, he begins returning to Earth at the same speed. Once again, the twin that stayed on Earth sees the ship as shortened to 1/23 its length. When his brother arrives back at Earth, after the twin that stayed on Earth has watched the ship travel 23 light-years at nearly the speed of light, he has seen 23 years pass and is now 81 years old, while his brother, who made the trip, is just 37. Now let's look at what the twin that makes the trip sees. It will make a difference in your understanding of this problem and special relativity as well. The twin that is making the trip says goodbye to his brother. They are both 34 years old. He then sets off for Gliese 393 at 0.999 times the speed of light, which has a gamma factor of 23. As a result, he sees the distance between Earth and Gliese 393 shortened by a factor of 23, reducing it to a single light-year. When he arrives at Gliese 393, he has seen the universe go by at nearly the speed of light for the distance of 1 light-year, and he is now 35 years old. After surveying the system for a year, he heads back and once again sees the distance between Earth and Gliese 393 shortened by a factor of 23 to 1 light-year. Upon returning to Earth, he has seen the universe passing by him at nearly the speed of light for the distance of 1 light-year, and he arrives back at Earth at the age of 37, finding his twin brother to now be 81. So as you can see, the so-called twin paradox is really not a problem for special relativity. It simply results from not looking at all the pieces of the puzzle. If you liked this video, please press the subscribe button to subscribe to this channel, and also give it a thumbs up. You can also support this channel with a donation by using the link in the description.